Okay, so let's look at this problem. And so what do we have? We know that we have an electric kettle that has power in of 1250 watts. Okay, so before we get into madness of what formula, how do I set it up, let's just step back and think about this conceptually. So what do we know? We know that we have 1 liter of water, and what we need to get out of this is that this kettle can bring the water, uh, heat up water, okay, to desired boiling temperature. We know that we will need 310 joules, kilojoules of energy here. So we know that energy out that I need to get out of this kettle is 310,000 joules, right? If I don't get this energy, I will not heat up that water. So that's my desired outcome. What I need to get out of it is this many joules of energy. Now we know that what goes into that kettle, the energy that goes in, what goes in, energy in, is actually 1250 watts, right? So the power in, which means that every second 1250 joules of energy goes to kettle. Now, what does that mean? If my kettle is 100% efficient, that means that kettle will give, so at 100% efficiency, 1250 joules per second goes to water. So what does that mean? How long is it going to take me? Well, I know that the time, it's going to be energy out that is needed divided by what goes in every second, which is 1250 joules. And if I do this, that means I have 310,000 over 1250, which is equal to approximately 248 seconds, which means that that would give me about 4 minutes and 8 seconds to heat up this water, right? So again, let's summarize a few things. The key thing is to realize, what does it mean that something is 100% efficient? That means that if this kettle is taking 1250 watts every second, it's giving the same 100% of it into what it needs to do. Now, I know that this is what I need to heat it up. If that's what goes to that water, then the time it's going to take is 248 seconds. All right, so now let's continue with this, and now let's look at the part B. So now we have a kettle that is 60% efficient, okay? Now we are doing the same task. There is water in here, we need to heat it up, and we need to get the time it's gonna take. Now I just realized I need to erase this part. So I'm sorry, that's from old one. So the key idea here is, again, we're gonna get the time, and the time it's gonna take is whatever energy out over whatever goes in, energy in water per second, right? So we know, again, it's going to be 310,000 joules over something. Now the question here is, what is that something? Well, the efficiency is now changing thing. I know that what goes into the kettle is 1250 joules per second, but it's only 60% efficient. So what does that mean? What goes in water is only 60% times 1250, what would go normally. So only 750 joules per second goes into heating that water. So in this case, it will take less energy. So that means in this case, if we do this calculation, we would find out that's about 413 seconds, which is approximately 6 minutes and 53 seconds. Right? So in this case, it takes longer because it's only 60% efficient. Okay. Now in the third question, what could you do to make it faster? Well, I'll let you be creative on this one and we can discuss it in next class.